Good evening, one and all. My name is Paul Varghese. I am working as a software engineer in GeekyAnts. Today, I will be talking about how to build a decentralized application using Flutter and Solidity. So, before we begin to build our app, there are a few concepts that we should be aware of. The first concept is what is blockchain. So, if someone asks me how can you explain blockchain in one sentence, I will tell them in a manner like this. Blockchain is a distributed immutable ledger which is completely transparent. So let's go through the three important words here: immutable, distributed, transparent. So what is immutable? Let's say someone added some data to the blockchain. Once the data is added, no one can change it. Distributed. All the network participating in the blockchain will have access to the distributed ledger. Transparent. Since everyone is having access to the same ledger, the transactions will be transparent. So some of the important concepts inside blockchain are blocks, nodes, and miners. So what are blocks? Basically, every blockchain is made up of multiple blocks linked together. Each block will have a block number, a field for data, previous hash, and hash. Hash is basically like the fingerprint of the blockchain. Hash can be used to uniquely identify that block within the blockchain. And the previous hash points towards the block that came before it. So if you look in the picture, you can see in block number 2, the previous hash of block number 2 is same as the hash of block number 1. The next concept is miners. Whenever an user adds a transaction to the blockchain, it is the responsibility of miners to add this transaction to the blockchain. Miners do this through a process called mining, where they solve a complex mathematical problem. Then nodes. Every computer that runs the blockchain is called a node. If you see in the figure, we can see computer A is running its own blockchain, computer B is running blockchain, and rest of the nodes, computers are also nodes. Now, to understand the working of blockchain, I have found a good website by Andrews Brownsworth. So basically, this is a block. A block will have a block number, a block nouns, a field for data, and a hash number. Basically, when we say a transaction is added and miner is like doing solving a mathematical problem, basically every blockchain will have its own different sets of problems. In this example, the miner have to produce an hash that starts with 4 zeros. Let's say I added some data to this block. So you can see after adding this data, the hash of the block is completely changed. So when a miner needs to add it to the blockchain, he needs to find a hash in such a way that it starts with 4 zeros. So the miner cannot change the block number or the data. The only thing the miner can change is the nouns. So when we click on the mine button, we can see that the nouns change and the hash of the new block is starting with 5 zeros. Now if you go to, so this is for one single block. If you go to a blockchain, there will be more than one blocks linked together, and the first block is called genesis block because it is the first block and its previous hash will be 000, and we can see the previous hash of this block is same as the hash of this block. And if you go ahead, the previous hash of this block is same as the hash of this block. So whenever someone tried to change the data of one block, all the blocks, the hash of that block will change. Also, all the blocks after that block will also be corrupted. So if someone, let's say, okay, we will mine this block and we will mine this block, then we can change the data in blockchain. That won't work. So that's where the distributed part of blockchain comes into play. Basically, there will be blockchains, there will be multiple blockchains of the same instance running on multiple computers. So even if someone were able to corrupt a blockchain and mine it is able to mine it, the hash of that will be, the hash of this will be different to the hash of this and will be different to this. So when so in this situation, when conflict like this come conflict like this come in the blockchain, majority is taken. So we can see in out of these three peers, two of them have same hash and only this one have different hash. So this will be kicked out of from the blockchain or will be forced to revert to its original position. So that was a brief overview about how blockchain work. So I will just summarize it. So basically what happens is once someone made a transaction, it will be stored in a place called mempool. When it is stored in a mempool, all the miners tries to solve the mathematical problem, trying to find the nouns. Once, if any miner was able to find the nouns first, that miner will be rewarded, and it will be validated by rest of the miners. After the validation phase, the block will be added to the blockchain. Now, some of the applications of blockchain include blockchain can be used for payment processing and money transfers. Blockchain can be used for data sharing. Blockchain can be used for creating smart contracts. Blockchain can be used for copyright and royalty protections. Now, the next concept is what is Ethereum. So, we can simply define Ethereum as a protocol that runs on the blockchain technology. Basically, Ethereum provides us tokens called Ether that can be used as digital currency. Ethereum also allows us to create smart contracts. Ethereum also provides us wallets that will have address that will store our private keys, which can be used to access the Ether stored in the blockchain. Now, what are smart contracts? Smart contracts can be basically defined as contracts that are written in program rather than in words. So basically, smart contracts are simply programs that will be stored on blockchain, and they will run when a predetermined conditions are met. Like, these are mainly created so that no intermediary involvement is necessary. Now, the next, like, Ethereum is always compared to Bitcoin. So the main difference between Ethereum and Bitcoin is that Bitcoin only provides us with tokens that can be used for as a digital currency, while Ethereum can be used as a digital currency as well as it can be used to create smart contracts. Now, what is Truffle and Ganache? Basically, Truffle is a smart contract development framework. It basically allows us to compile smart contracts, deploy them to Ganache. Ganache is basically a local blockchain setup that we can use to test our contracts. So, like, with the basic concepts, like, we are now somewhat familiar with the basic concepts, we can start building our smart contract. So for building the smart contract, I am using Remix IDE. Basically, it is a online code editor which supports Solidity. Basically, we will be building our smart contract on the Solidity programming language. So basically, I have created a file called todo.sol. All the extension of a Solidity programming is .sol. So the first line contains the license identifier. The second line contains the version of the Solidity we will be using. And to create a contract, we must use the keyword contract, and we should give a name. And inside that, I have defined a variable called task count. Basically, it has a public identifier. Whenever we define any variable as public in Solidity, we will automatically get a getter function for it. And I have defined a constructor. So whenever this contract is deployed for the first time, the value of task count is initialized to 0. Next, I have created a structure called task. Basically, it has three variables in it: an integer, an index of type integer, a task name of type string, and a is complete of type boolean. Also, I have created a mapping of integer to our task structure and named it as to-dos. Basically, what this does is, like, we can use it like a basically we can use this as a map. So we can do like to-dos of 0, and we can assign the instance of task to this. So basically this allows this, and I have created 4 functions. Basically the first function is create task, which accepts a string variable of task name, and it creates a new instance of task using task count, task name, and initially I am setting the is completed as false, and it will be stored in the to-dos, and I am incrementing the task count out after that. And there is something and the next function is update task. Basically, it will receive 2 parameters. One is task ID and another is task name. It will first fetch the current to-dos from our task and saved it in a variable called current task, and it will just update it. And next is toggle status. Basically, this function is used to change the status of to-do from completed to is completed or vice versa. Basically, it does the same operation as update task. And delete task is also another function I defined. Basically takes an ID and deletes the to do on that ID. So this is an overview of our contract that we will be using. And to compile in Remix IDE, we can go to this button and click on it. And if we click on compile to do.sol, it will be compiled. Whenever we compile a smart contract, we will get 2 components. One is ABI and another is bytecode. ABI stands for Application Binary Interface. basically if you copied it and paste it in a notepad, so basically this is ABI. Basically ABI provides all the functions that our contract has. Basically ABI can be used to interact, like whenever an application or another smart contract want to interact with our smart contract, they can use ABI. Also they provide us with bytecode. Basically bytecode is the instructions of our smart contract. Basically the only bytecode will be deployed on the blockchain. So that's it. And after compiling, we can deploy that in Remix ID itself. So if we click on deploy, we can see our contract has been deployed. And if we click on task count, for now it will be initially 0. And like we can create, the good advantage of using Remix ID is that we will get buttons that will be pre-built, so we can just test our contract very easily. So we can write learn HTML and create task, and we can see the task has been created. And if we click on task count, we can see one has been incremented. And if we click on the 0th to do, we can see index 0 learn HTML has come and completed is false. Also, like we can toggle the status with the ID, and if we click on that, we can see it has become true. So this is how we create a contract in Remix ID. The main disadvantage of using Remix ID is like when we are creating like large contracts, it will be very difficult to create. So what we will do, we'll shift to Visual Studio Code. So to run the smart contract in Visual Studio Code, we will use Truffle. Truffle is basically Truffle can basically use to compile our smart contracts. You can install Truffle by going to their website and using the command npm install -d Truffle. So I will just copy this contract, and so I have created two folders. One is client and one is server. Client is like our front end, where I will be building the user interface using Flutter, and in the server part I will open it in terminal. And we can initialize a Truffle project like with the command Truffle init, just like we initialize a node command using npm init. After initializing, 4 folders will be created. One is contract folders, where we can paste our where we can create our contracts. Next is the migrations, where we will write our migrations, and one is testing folder, and one is like configuration folders. So in the contracts folder, we will create our todo.sol and we will paste it. So in the migration files, we have to give migration commands. So how we name a migration file is by first specifying the sequence number. So since this is the first contract to be deployed, I will start it with 1, and we can give any name. So I will name it initial migration. So the advantage of using numbers is that, let's say we want to like migrate 10 contracts at a time. So we can define the sequence in which these contracts will be migrated. So in this file, we can just import our thing. So we can deploy our contract, and we have to give the name as to do. And once we have written the migrations file, we can go to the terminal, and we have to first compile the contract. To compile the contract, we can use the command truffle compile. And the contract has been successfully compiled. And if we go to the build folder, we can see there will be a JSON file generated, and basically this JSON file contains our API, which we require to interact with this contract, and it will also contain the bytecode which can be used to deploy to the blockchain. So for like testing purposes, we will be using Ganache. Ganache basically provides us with many testing accounts where we can like deploy our contract. Like if we don't use Ganashe, we may have to pay like original money for testing and all. So if we open Ganashe, we have account sections where we will have different dummy accounts with 100 Ethereum in it. And if you click on this key, we can get their private key also. Basically, private key is used to access the tokens stored in blockchain. And if you go to the block tab, we can see there is only 0 blocks. So let's migrate, let's deploy our to deploy our smart contract to the Ganashe, we just have to type the command truffle migrate. So we can see, if you open Ganashe, we can see one block has been mined, and if you click on this block, we can see it is a contract creation block. Basically, it will give us the contract address. This is the address where our contract has been deployed. Also, this is the from address, like from which key it was like deployed. If you go to account section, it will be first account. We can see like little bit of Ethereum has been like deducted from his account because he has migrated the contract. And if you see, this contract will be same as this address will be same as this address. So this is how we migrate. Like now we have deployed our contract to the Ganashe. Now we can copy this todo.json file since it contains API, which can be used to like interact with this contract in the front end. And if you go to the front end, basically we have to paste it. That in the front end I am using Flutter. Flutter is basically Google's framework that can be used to like create mobile applications, websites, etc. So if you go to the assets, we can paste that to do JSON file there. And in the pubspec.yaml, the packages I will be using for this project are provider, which is used for state management. Then next is web3 dart, which is basically used to like interact with the blockchain, and HTTP package for like providing a client for the web3 dart. And here I have like so here I have defined the path for the assets that we have just defined. Now I will just run it. So by the time our app is running, I will explain the folder structure. Basically in lib there are 4 folders. One is contract, model, screens, widgets, and main.dart. The important file here is the contract folder. In the contract folder there is a file called contract.dart. Basically this is the file that is responsible for talking with our smart contract. Basically this contract file has a RPC URL. Oh, just a second. I think we had one more step in the server, I guess. Like in the Truffle config file in Truffle config file, there is one section called development. In development, we have to uncomment this, and we have to give the host, like where should we deploy our contract to, and we have to give the port number. So we just have to copy this, and we just have to paste this. And for now I think we can delete this, and we can just do compilation again. So that was one small change that I forgot. We can just do it again and it will work. We can just compile again. And we will see one more block will be like 2 blocks will be now generated. So this is, we have like migrated again, so one more contract creation block has been created, and we can copy this, and in assets we can remove this file and paste it, and yeah, rest of the things are same. So coming back to the contract for file, basically it requires an RPC URL, which is basically the URL where our contract has been deployed. So this URL we will get from Ganesha here. And after that we have to like provide a private key, like whenever we are like interacting with the smart contract and we are changing the state of the smart contract, we have to pay some gas. So for that gas we need ETH tokens. So to access these tokens we need the private key. That private key I have taken from this user and I have just copied this and pasted here. And after that we need an instance of Web3 client. Then we will need the API code like to interact with the smart contract. Then we will need the Ethereum address. Then we need the credentials for interacting, and we will need a variable called deployed contract, which basically makes interacting with the smart contracts easier. And when this like contract is like instantiated, I have created an init contract. Basically what this function does, it first creates an instance of Web3 client and provides the RPC URL and the client. This is coming from the HTTP packet, and it is like loading three functions: get API, get credentials, get deployed contract. So basically in get API, basically it is fetching this assets to do JSON from our root bundle, and basically it is just decoding using JSON decode, and we are getting the API in setting the API in this variable, and also Ethereum address we will also get from the same JSON file. So these two variables we are initializing here. After that we are getting the credentials. We already defined the private key. So from that private key we can get the credentials, so that we are doing here. Then we have the deployed contract. To get that contract we can use deploy contract function, and we have to just pass contract API from JSON. We have to pass the API code and the name of the contract, which is to do, and we have to pass the address where it has been deployed, which will be in Ethereum address. Then basically there are two functions that I am using to interact with the smart contract. One is call function and one is send transaction. Basically the difference between these two functions is that whenever we just want to read from the blockchain, like we don't need to like change the state of the blockchain, we will use call function. And like for example, when we want to fetch the to-dos, we will use the call function. And whenever we want to like send the we want to change the state of the blockchain, like changing the status or adding new to-do, we will use the send transaction. So call function does not require any gas, while send transaction will require some little bit of gas to make the transaction, and this function will only mine a new block. So basically in this we are using the Web3 instance and just using call function here, and we are just sending transaction here. And after that I have defined a function called get to dos. Basically it will use the call function to get the task count, and based on that task count it will fetch all the to dos and save it in the to dos variable and return it. Also there is a function called add to do. Basically it takes a string to do name as parameter, and basically sends the transaction to the create task function that we created in the smart contract. And delete to do and change to do status does the same thing. Just it takes the parameter, pass into that parameter, and calls that corresponding functions. And if we go to the main file, we will see there's a dash widget. In the dash basically there's a basically a future builder that I have provided the get to do function, so it will keep on loading till the to dos have been fetched. Then there is a floating action button I have used to get the input from the user. Then if like the data is loaded, I am returning a to do list view. Basically it takes a to do. I have also created a model where class to do with ID, name, and is completed. So basically whenever like that every to do is loaded, this widget just displays it. So that's an overview about the front end. So if you go to the app, we can see there are only two blocks. So if you open our simulator, since there are no to dos left, it is showing press plus to add. So if you press on this button, it will say add a to do. If I add learn HTML and press on add, we can see a new block has been mined, and this much gas has been used. So whenever we like add something to the to do, or let's say I change the status of to do to completed, it will add another block. And if I change the status again to not completed, it will add another block. So whenever we are like changing the state of the smart contract, a new block will be mined. So yeah, basically this was an overview of how to build a decentralized application using Flutter